Okay, so we have collected our data for the standard curve for the mass of copper and brass using copper nitrate solution. What I would like you to do first, before you try to make the graph, is to set up your table. And on the left side, on the leftmost column, you should have concentration in molar. And on the right column, you should have absorbance. And those would be your absorbance values that you calculated when you were reading it using the spectrophotometer. So after you've got your data formatted just like I have, you will select these two columns. And then I want you to go under Insert and hit Chart. A chart will pop up, and as usual, it always puts it in kind of a weird setup. So the first thing I want you to do is to actually change the type of chart. So go down until you find XY scatter and select that. After that, click on Customize, and under Customize it will allow you to do chart and axis titles. Okay, and in this case what I'd like you to do is change the chart title to Copper to Nitrate Standard Curve. After you're done doing that, go ahead and close that and open up Series. You will scroll down in Series until you see Trend Line. Select Trend Line. Leave it as linear, and then continue to scroll down. Select Show R Squared, and for the label, change it to Use Equation. You do want to see the equation here. You will use it to calculate your unknown. Okay, at this point, we can get out of this, as it will not let you easily put the labels in when it's in this form. So we're just going to close this. We now have our graph. We're going to scroll it over here, and then under our graph we can give our vertical and horizontal axis names by double clicking on it and then opening up the right menu and going under Chart and Axis Titles and select Horizontal Axis Title, and it will allow us to type it now. So we can now put in, and I want you to use actually the chemical formula. Okay, so type in copper nitrate molarity. Okay, and then hit Enter. And close out of that one, and it will pop up down here. And then on this side, I want you to double click on this, and again, go under right click and select Vertical Axis Title. And we will now type in absorbance and give it the wavelength that you chose in the class. I'm going to type in the wavelength that I ended up using, which is 640 nanometers. Okay, and at this point, you now have a graph with a y equals mx plus b curve and a linear slope. And you will notice that the r squared equals 1, which means that all of my data fits very nicely in my standard curve, and I do not have to get rid of anything. What I would like you to do is to actually manipulate your equation such that it will allow you to calculate the concentration of the unknown. In this case, the concentration of my brass sample was my absorbance was 0.262 for my brass sample. So this is actually the y in my y equals mx plus b equation. So what I have to do is to manipulate my equation so that I can determine the x, which is the concentration of my copper in this particular solution that I dissolved my brass in. So what I do is I manipulate my equation starting with this. So y is actually equal to A, that's the absorbance, and I have it's equal to 2.71x plus 0.0033. So the first thing I'm going to do is I'm going to manipulate my equation such that I have A minus 0.0033. Okay? So I'm moving my intercept over. I will then divide by the slope, which is 2.71, in order to get my x by itself. So what I would like you to do here is I would like you to put this up here. So this is the equation I'm actually going to type up here. And the way I do it is I just hit equals, and I want to select my absorbance that I've already typed in on the chart, so I'm going to put in B8. And then I'm going to put parentheses around it. Always use parentheses, it doesn't work if you don't, and subtract 0.0033 from it. And then I'm going to divide that whole thing by 2.71. And when you hit enter, it will calculate your concentration of your brass sample. Now, the important thing to note is that make sure that your number makes sense. So for example, my absorbance was 0.262 for my brass sample. And if I go up here and look, the closest one to it was about 0.1, which was 2.71 absorbance. So my number actually makes sense. It's a little bit less than 0.1 molar. Okay? Make sure that your number makes sense. If it doesn't, check your equation to make sure that it is good. What I'm also going to show you how to do is something you will do later. So you will get data from both groups, and I'll also give you the data for mine. Mine is actually this number right here. Okay? So what I'm going to do is I'm going to take these three numbers, which I just randomly selected. Okay? You will use my number and the two groups' numbers. And then I want you to calculate the mean and standard deviation using this spreadsheet program. It's actually not that hard. And in fact, if you use the program, you don't really have to even know how to calculate mean and standard deviation, which is why when I teach it normally, I will actually make them calculate it first rather than just use this computer program so that I'm sure that they understand what mean and standard deviation are. However, for the purposes of this, we don't need to know this. So the mean, as you know, is take these three numbers and divide by 3. So you can either do that or you can actually use the functionality of this system. So if you go under Insert and you select Function, average is one of those ones that pops up. And average in this case really does mean mean. And in order to select the data that you want to average, you can just select the data right here and then hit Enter. And it will automatically calculate your mean for this data. It will also calculate your standard deviation as long as you type in ST, and you see how it pops up standard deviation, and then you will select the same data again, close the parentheses and hit Enter, and it will also calculate the standard deviation for your data. The smaller the standard deviation is amongst your data, the greater the precision of your data. So the smaller this number is, the higher the precision. And when you are done with all of this, you have the choice of either printing this entire sheet out and printing the graph separately, or either sharing this document with me, or my preferred suggestion would be to actually copy this information into a Google Doc that is part of your lab write-up and submitting it to me. Okay, so you have these three options. And with that, you are done prepping this lab.